In this example, we have a straight line that passes through 2 points. That's all that has been given to us, because the moment I give you 2 points, a particular straight line gets fixed, and we have to calculate what is the equation to that straight line. So here is the 3D space, and here is the straight line. Before we continue, we're going to ask ourselves the same question we asked last time. What is the meaning to find an equation to a straight line? Well, what it means is the following. If I have a particular point over here, let's call that point as P, and has a position vector R, then what is the condition for this point P to lie on my straight line? Well, we saw that last time. Let's redo it very quickly. If I know the direction ratio of my line, which means I know the direction ratio of a vector which is parallel to my straight line, and also imagine I know a point that lies on my, okay, so if I know A and if I know V, then the condition for P is found out this way. We say, look, OA plus AP should be equal to OP. That's just the vector addition, okay? But if P lies on the straight line, then AP must be parallel to vector V. That's how we derived it. And because of this, the equation we were able to come up with was OP, that is R, here it is, R, must be equal to OA, that is A, and A is in pink, plus AP, but AP in this specific case must be parallel to vector V, and any vector parallel to vector V can be written as some constant lambda times the vector V. And different values for lambda gives me different points on the straight line. Okay, but this time we seem to have a problem, and the problem is we don't know what V is. We don't know the direction ratio of the straight line because in the question only 2 points are given. But guess what? I know 2 points. So let me call this as point A. So point A in our example is 0, 3, minus 5. We also know a second point, and the second point, let's say, is this one, point B. That is 2, 4, 8. And my question is this: can't we use these 2 points to calculate what the direction ratio is? Of course we should be able to do that, right? It's just simple vectors. So we can calculate the direction ratio of AB, and the way we can do that is just OB minus OA, right? Again, triangle. So AB has to be equal to OB minus OA. Okay, so what is OB minus OA? That's 2 minus 0. Again, it's my shorthand notation. No I caps and J caps. It's supposed to be there, not writing. 4 minus 3 and 8 plus 5. So that is 13. Okay, and guess what? This is my direction ratio. So I have found my vector V, the vector which I like. That's the vector which is parallel to my straight line, and therefore now I can write the equation to my straight line. It's just going to be R equal to point A. A is any point that lies on my straight line. I could take A, or I can even take B. I'm going to take A in this example. So 0, 3, minus 5 plus some random constant times V, and I know the direction ratio of V this time. I found it out. 2, 1, 13. Ta-da! There we have it. That is the equation to the straight line that we wanted. Now you could have also written R equals B, this vector over here, this position vector over here, plus lambda times. So that's equally valid. Okay, so you can do that. I'm not going to write it over here. Let's write the Cartesian form very quickly. To understand the Cartesian form, remember that there is an x, y, z over here, okay? And hence we can write equation for each coordinate of the point that lies on my straight line. Each coordinate for point P. And so an equation for x would be x equal to 0 plus 2 lambda, so that's just going to be 2 lambda. Y equal to 3 plus lambda, and z equal to minus 5 plus 13 lambda. And from this, all we have to do is calculate what lambda is. So from here we have x divided by 2, y minus 3 divided by 1, and we have z plus 5 divided by 13. Ta-da! There we have it. And that is our Cartesian equation to the straight line. So notice that we use the same concept as we did last time with a little bit different problem. You could also write the parametric form. This itself is the parametric form over here. Alright, see you next time.